Hey guys, welcome back. This video is over dimensional analysis, so make sure you've got your calculators ready and your pencil sharpened, and you might want to keep this video somewhere that you can get to it, because you may find yourself coming back to do it a lot, especially if you struggle with math. So what is dimensional analysis? It is a way of converting from one unit to another, and we're going to do this a lot in chemistry, going between atoms and molecules and moles and grams and liters. You're going to use it a lot. So we're going to teach it to you now. Hopefully you learn it now. That way when we get into it in a few weeks, you'll be ready to go. So there are 9 steps to it. Once you do this enough, you don't need to follow the 9 steps, but if you're really struggling with it, please keep those 9 steps down in your notes and just follow them step by step and you can't go wrong. So step 1, draw the dimensional analysis grid. In my class, it will look like train tracks. Okay? In other classes, it might be like a fraction. It's the same thing. I prefer the train track grid. Step 2, write the given number and the unit in the upper left corner. The given number is the number in the question. That is your given. You'll hear me say it a lot. That's what I mean. Number 3, copy the unit from the upper left corner to the lower right corner. So if we're given 10 grams, that's where we are right now. Step 4, write the desired unit in the upper right corner. Say I want to go to grams to kilograms. So 10 grams, and I want to go to kilograms. That's where I would be right now. Step 5, fill in the correct numerical relationships between the 2 units. So if I've got 10 grams, I've got grams here and kilograms here, this is where you might need to go back to your chart that we had, the unit of measurements. There are 1,000 grams in every 1 gram. That's where that chart's going to help you out. Number 6, cancel any units which appear in both the numerator and the denominator. So if we've got 10 grams, 1,000 grams equals 1 kilogram. Well, the grams are in the top and bottom, so we're going to cancel those out. Number 7, multiply everything together that is above the grid and divide by everything that is below it. So in this one, we do 10 times 1, make sure you use your parentheses, divided by 1,000. Step 8, express your answer in the same number of sig figs as we were given the answers. So it would be 0.1. Well, so however many given sig figs you have is the sig figs you have in your answer. Number 9, the units which did not cancel the unit for the answer. So here, our grams canceled, so our unit for our answer will be kilogram. Now I know I went through that fast, so please pause, go back, rewind, listen to it over and over again, watch how I did that one simple grid, because you're going to be doing a lot of these. So let's go to work. How many hours are in 190.7 minutes? So let's draw our grid. Put our given, which is this one, because it's in the question, so that's our given, in the upper left corner. So 190.7 minutes. Put the given units in the bottom right. There we go. Put the destination, the units we want, which is hours, in the top right. Now we're going to fill in the relationship. There are 60 minutes in every 1 hour. Now we're going to cancel units. There's minutes in the bottom, there's minutes in the top. Now we're going to multiply the tops and divide by the bottoms. 190.7 times 1, make sure you use your parentheses, divided by 60, and that will give you 3.178 hours. Now we got to check our sig figs. 60 is a conversion factor, so you do not use that as a significant figure. If you're confused about that, go back into the sig fig video. You'll see that they don't count. So we've got 1, 2, 3, 4 in our question, 1, 2, 3, 4 in our answer. So number 2, draw your grid. Your given is 378.4 centimeters. Move that unit to the bottom right. Our desired unit now is meters. There are 100 centimeters in every 1 meter. Cancel your units. Tops divided by bottom. So it's 378.4 times 1. It won't always be 1. divided by 100, and you get 3.784 meters. And the next one, draw your grid, make it a little bit extra long this time. Your given is 4.32 times 10 to the negative 4 grams. Since grams are here, milligrams are here, there are 1,000 milligrams in every 1 gram. Cancel your units. And you have 4.32 E negative 4. Don't forget that E. Times 1,000 divided by 1. And that will give you 4.32 times 10 to the negative 1 milligram. So those are simple one-step problems. But with this, we can go to two-step problems, and eventually we go into 3 and 4 and 5-step problems when we get later on in the year. But to go from one side of the base unit, so say we're going from milligrams to kilograms. We're going to go from milligram to gram to kilogram. Or go backwards from kilogram to gram to milligram. So in our example, we know it's going to be 2 steps now, so I'm going to draw a 2-step grid. It's always the same though. We're going with our given 231 millimeters. Okay, millimeters in the top left, millimeters go in the bottom right. Now we always go back to our base units, so here's our meters. Got meters in the top left, we're still going to move that down there to the bottom right, and eventually want to be in kilometers. Now from here, all we got to do is put in our relation values. There are 1,000 millimeters in 1 meter, and 1,000 meters in 1 kilometer. Now, let's do the math. 231 times 1 times 1, now here's where your parentheses really matter, divided by 1,000 times 1,000. That will give you 2.31 times 10 to the negative 4 kilometers. There's a little bit prettier for you. So now you got 2 practice problems. You can go ahead and try those. I'll keep on working them out.